Let's have a look at an example of relative frequency. And relative frequency is really just a way of sort of helping us estimate the probability of an event or a situation where it's practically impossible or at least very, very difficult to determine using theory alone. So a particular sporting team won 5 matches, drew 3, and lost the rest in the last 20 rounds. So we can see just from this situation alone that there's really no way to determine, in theory, what the precise probability is going to be of a win, lose, or a draw. So we do have some data though, and we do have some historical observations that we could make. So part A, estimate the probability of that team losing the next round. Okay. Part B, if that team was to play 100 rounds, how many of those would they be expected to win? And part C, which I put in just to get you thinking a little bit more about, I guess the advantages and I guess the disadvantages or the limitations of this particular model. State a limitation of it. Is it accurate? Is it something you could rely on in the long term? So let's have a look at part A. Estimate the probability of the team losing the next round. Well, let's look at the data. Okay, so the data states that in the last 20 rounds, we've won 5, drew 3, lost the rest. So for part A, okay, the number of losses out of 20, so okay, is equal to 20 matches played or 20 rounds minus the number of wins minus the number of draws, and we get 12 losses. Okay, so the probability of a loss in the next match, okay, is going to be 12 over the relative frequency, the number of games played. So that's the relative frequency of a loss is 12 over the number of games played, which is 20. Okay, and that gives us, well, we could simplify it to 3 on 5 or 60%. Okay, doesn't really matter. We can leave it as a fraction. That's fine. Okay, so either one of those answers is sufficient. Okay, so for part B, if that team was to play 100 rounds, how many of those would they then be expected to win? So again, going back to the data, we've got 5 wins out of 20. Okay, so the number of wins in 100 rounds, okay, is really equal to the probability of a win in one round. So we're going to use the relative frequency of a win, which is 5 over 20, and then we're going to multiply it by the number of rounds, okay, and that gives us 25 wins. Okay, now part C is really just a bit of a discussion, but I might just throw something out there. Could this be used in the long term? Could this model be used? Are we guaranteed that this is going to continue, that this particular team is going to win 5 out of 20 games, they're going to draw 3 and lose the rest? Well, I would say it's unreliable for starters because it doesn't take into account weather conditions, it doesn't take into account player changes, it doesn't take into account the coach or the nature of the opposition as well. The team could move a division. I mean, there's so many limitations. You don't even know where to start really, but all you got to do is just state one. So any one of those that I've mentioned would suffice, or if you have any of your own, as long as you can justify it, would be correct.